Okay, in this video I'm going to do electric fields number 1. So it says a charge Q1 has 5 microcoulombs of charge and it's at the origin, and a second charge Q2 of negative 3 microcoulombs is on the x-axis 0.8 meters from the origin. So let's just draw this, okay? So here's the origin. So right here I'm going to have a 5 microcoulomb charge. And then a second charge is 0.8 meters, so over in this direction, 0.8 meters, and that is negative 3 microcoulombs. And we want to know the electric field at a point on the y-axis a half a meter up. Okay, so here, about here, we'll say that's 0.5 meters. And I want to know the magnitude of the electric field there. Okay, so what we need to do is we need to first determine what the electric field lines look like, and then calculate their magnitude, and then we'll have to do some vector math, okay? So the first one points towards or away from the positive, right? So the electric field at this position as a result of the positive charge would be straight in this direction. So that's like E1, okay? And then here there's an electric field that points towards that one. Right, so towards the negative here. So this is E2. Okay? Now here. And now the other thing that I need to figure out is the distance. So I have a right triangle right here. So I know the distance between these two. That one's simple. So why don't we just start with that one? And remember that an electric field is equal to K times Q, that is making the electric field all over R squared. Okay, so I've got 9 times 10 to the 9th times 5 times 10 to the negative 6 microcoulombs all over 0.5 squared. So that will give me the magnitude of this electric field. Okay, let's punch it in. 9 e to the 9th times 5 e to the negative 6, and then divided by parentheses 0.5 squared. Gives me 1.8 times 10 to the 5th. So here, 1.8 times 10 to the 5th newtons per coulomb. Okay? Now I want to figure out what E2 is. Alright, so in order to figure out E2, I actually need to figure out the distance, and so I just need to use the Pythagorean Theorem to figure out the hypotenuse of that triangle. So 0.5 squared plus 0.8 squared equals, and then second square root, second answer. So 0.94 is the distance here. Right? So then I'm going to take figure out that electric field. So this is electric field 1, this is electric field 2, is equal to, again, KQ over R squared, so 9 times 10 to the 9th times negative 3 times 10 to the negative 6. And again, this really doesn't matter. I'm not even going to put the negative in there because it's all about the direction that matters, okay? And then all over 0.94 squared, okay? So 9e to the 9th times 3e to the negative 6th divided by 0.94 squared. Oops. There we go. So 1, 2, 3, 4. So 3 times 10 to the 4th. Okay, and that's newtons per coulomb. Right, so now we have, let me move around so my lights actually come back on. All right, so now we have those two vectors, and now we actually have to figure out the net, right? So we have to find the x and y components of this vector, okay? So we need to know the angle, and in order to know the angle, we need to use some sort of trigonometry, right? So I'm going to shoot for finding this angle because that would be the same as this angle because they're complementary angles, right? So I could do opposite over adjacent and then do inverse tangent to find that, right? So I have 0.5 over 0.8 0.5 divided by 0.8, and then second tangent, second answer. So 32 degrees is what that angle is. Okay, so then we just need to find the components of this vector. So remember, this is 3 times 10 to the 4th. So the 3e to the 4th times the cosine of 32 gives me 2.5 e to the 4th. So 2.5 times 10 to the 4th for that. So that's for the adjacent. Then we need to do the opposite. So the sine of 32 times 3e to the 4th, and that gives me about 1.6 times 10 to the negative 4th. Okay, so the sum of all my x components, so my ex is equal to 2.54 times 10 to the 4th, right, because this doesn't have an x. And my y would be this minus this, right? So we're going to do 1.8 e to the 5th minus 1.6 e to the 4th. Gives me 1.6 times 10 to the 5th, right? So those are the two sides of the right triangle. So we just need to then use the Pythagorean theorem to find the resultant. So let's see here. We've got 2.5 second e to the 4th squared plus 1.6 e to the 5th squared equals, and then second square root, second answer, and it gives me 1.6 times 10 to the 5th. So okay, and then let's kind of look at the angles. So if I draw them again, we're going to start here, and I'm going to do, this is E2, and then this is E1, which is a lot bigger than E2. So that's going to be my resultant in this direction. So I'm just going to do the opposite over the adjacent, or y over x, of my resultant vector. So 1.6 second e to the 5th divided by 2.5, so e to the 4th, and then do second tangent, second answer. And I get 81 degrees, and it's above the positive x axis. There we go. So back to some vectors, but really the point is that you know, electric field lines are vectors, and we know sort of the direction that they point, and we're able to calculate their magnitude, and then it's just going back and reviewing this stuff.